Welcome to the Resairchia YouTube channel. My name is Jorge, and in this video I will introduce you to the use of conditional equations with Modia. First, I will start by loading the usual packages: Modia for the simulation and plots to observe the results. Then I will create a vector for representing the time instance of our simulation, and then I will start with this very simple model. I define a parameter k and a variable v that it is initialized at 0. Then I write the equation that the derivative of v is equal to, if the actual value of v is less than 5, we ask, therefore the question mark, so it is easier to remember. If v is less than 5, then we use k, otherwise 0. Then, as always, we can instantiate and simulate to plot our results afterwards. While the model is simulating, I can recommend you to visit the control flow documentation in the Julia language website, where you can find all the documentation about all the conditional statements. Now, as you can see, our variable v will keep increasing until the moment that it becomes, as you can see, bigger than 5. And then after that, the curve becomes flat and the value of v remains constant. Let's try another model now. I have changed the definition of the equation, and the derivative of v in this case is equal to, if the cosine of the actual time instant, and to remove the units from the time variable, we need to divide by u, meaning that this means units, and the units, which is seconds. So, if the cosine of the actual time is less than 0, then the derivative of v is 0, meaning that the value of v will remain constant. Otherwise, it's the value of the cosine of that time instant. Now, again, we instantiate, simulate, and plot the result. So, as you can see, we can observe the variation of the variable v. This curve, since we are integrating the value, follows a sine curve. You can clean the screen by pressing Ctrl L if you don't know how to do it. Next, I will use the example of a ball falling. I define some acceleration, which is gravity, the radius of the ball, the initial velocity of it, and the initial height. Then the equation is the derivative of v is equal to, if h is bigger than the radius of the ball, then the acceleration is the gravity. Otherwise, it's 0. This is not a correct model. It doesn't represent an actual collision of a ball with the ground and its rebound, but it is what I need for the moment just to show how to use conditional equations. And then, in a similar way, to show how the height changes, we use the same condition, and the derivative of the height is equal to the velocity if it's bigger than the radius of the ball, otherwise it's 0. Again, we instantiate, simulate, and plot. We will see how the very moment that the ball hits the ground, both curves become flat. So, as we can see, the curve representing the height is decreasing its value until it gets right above 0, a distance equal to the radius of the ball, and then remains constant. The velocity, since we are falling, is negative, and then it becomes the curve flat at the moment that we touch the ground. This velocity is flat, it remains constant because we are using zero acceleration. As I said, the model is not correct, but my goal is just to illustrate what we are doing. The moment that we hit the ground, the model is not correct, but it shows my intentions. Using conditional equations is very useful when writing models. In any case, this video is not very long since I'm quite busy preparing something a bit bigger for the Modia tutorials. Stay tuned and thank you so much for watching. See you in future videos.